Hi everybody. Today we're going to be implementing Snake. We're going to be using C, specifically C99, and we're going to be using Raylib. So yeah, let's get started. All right, so we're going to actually start by just creating a little repository. I'm going to name it C Snake. I'm not going to bother with that. I'm going to set a template, and we'll look at that in just a second. But I'm going to create the repository, and you can just see it's a little Raylib template, and we now have C Snake. And it's going to take just a second, and there we go. Now I'm going to take this, go to iTerm, whatever your terminal of choice is fine. I'm going to clone this, and then we can actually see what's going on inside. So I'm going to open up Zed, and you can see this is not the right one. This is what we want. So in here, it's just a simple little thing, and then if we actually go into fix that. Now we're in there. I'm going to do mkdir. Oh no, actually I can just do get submodule init, get submodule update. Now we're going to clone Raylib. And then in just a second, once this thing is done, then we'll be able to actually make it. We're good now. So I'm going to just do setup.sh, and setup.sh is very simple. It makes the directory, we go into it, we cmake, then we build, and then we run the project. So we should be seeing something in just a second once Raylib is done building. And I think in just a second we'll be ready to go. I definitely think I'm going to update the template, which is, by the way, oh no, there it is. So this is actually where we're running the game. We have text here. I am thinking of updating this template so it's available on GitHub. But basically, instead of actually doing like a submodule, I think maybe just doing a DLL, kind of like what a TS Soding or Soding, however you say that person's name, would probably be a better approach. But yeah, so we have our Raylib set up, so let's actually get to implementing. All right, so the first thing I'm going to do is I'm going to actually change the resolutions that we're going to be working with. So since it's Snake, we're going to be going with basically a square, and it's going to be 1000 by 1000 pixels. And the other thing I need to do is I need to update this. So the Windows title is now going to be Snake. And then the next thing, now that we have like our initial little setup ready, is we're actually going to start implementing scenes. So the basic way we're going to be using scenes is with enums, type dev enum, and then we'll do this, and then we'll have scene, and we're just going to have two scenes. We'll have scene menu is equal to 0, and then we'll have scene game, and then there we go. That looks good. So those are our two scenes. And basically what we're going to do is we're going to implement basic logic real quick. So I'm going to have basically two different switches. The first is when we're going to be drawing, and then it's basically what I need to add here. Scene current scene is going to be equal to scene menu, right? And then there's basically going to be just a couple things to handle, which is right here. There's current scene, and then we can have it fill in stuff for us right there. And then I'm going to implement it like this, break. So we have our two different scenes right there. The one thing I don't like is I use this thing called ClangD format, which is very nice, but I want like the Muratori style where I can put like a break right there instead. And then I think this looks a lot better, but you just don't get that with this current format. So if anybody knows a fix, I would love to hear that. And then technically it's complaining because there's no default case, and we'll just break. It won't handle that. But now let's actually just do this real quick. We're going to do draw text, menu, scene, and we'll have it at like 450, 450, 40, and then color white. And then the other one we'll have here, this will be our game scene, and then we're going to change the background to be just black. And now if we run it now, cd build, cmake, build dot. So now we have like our little thing going. We don't have any like different behaviors. Actually, this is a little bit large. So I think I'm actually going to make it like 800 by 800, just so it's a little bit easier to like actually see the bottom of the screen. but 800 by 800. So I guess we'll just run just to make sure it looks okay. And that looks okay to me. Besides, like, obviously this is a little bit low now. But the other thing to handle is the case where we could switch actual scenes. So this is basically like, if we want to be kind of technical, this is going to be like where the render part of our game is going to go. So I'll do a big one right there, and then we'll do it like this. Render the game, and then we'll have update. Update the game. Something like that. And then we'll again have our little switch statement. Current scene, this. Now we have our missing stuff, and now we can fix this default. And we'll just break again. It's not great error handling, and we'll come back to it, I'm sure. But for now, let's just keep it like this. Break, break. And in terms of like the actual behavior, for the menu scene, there's basically just going to be like is key pressed, and we'll look for key space, or we'll look for is key pressed, and we'll look for key enter. And if so, we'll change the actual state of the game. So current scene equals scene game. And then in this one, basically, we're going to keep the default behavior of where if you press escape, the window should close. We'll evaluate to true, and then we'll be done. So we're just going to actually handle, instead of handling QN escape, we're just going to handle key escape. And then if so, this is pressed, right? We'll go to scene menu. And then the thing is this, and that's our problem. And so if we run this now, theoretically, we should be able to actually see what happens. So I'm going to press space, and you can see we're in the game scene. I'm going to press Q, and we didn't actually do anything because of this right there. Sorry about that. Let's rerun it correctly this time. Now if I press Q, nothing happens, but if I press enter, we'll go to the game scene. If I press Q, we go back to the menu scene. And now we have a working kind of menu system. What we need to do now is actually populate both the menu scene and the game scene, and then we'll have Snake. All right, so we're going to start with the menu scene. And just by showing how the scene system worked, we actually already implemented basically all the functionality of the scene. What we need to do now is we actually need to update the scene menu, like how we're actually rendering it. So what we're going to do is we're first going to do const star title, and this is going to be equal to Snake, because that's the title of our game. And then what we're going to do is we're going to figure out its width. So const int w, we'll just say tw actually, because this is going to come back actually. So tw is for title width, measure text, right? And then we're going to pass it in the title, and then what we're also going to do is t size is going to be equal to 40, and if it doesn't look good, we'll just change it. But we'll do t size is that, right? And then we have like how long in terms of the x coordinates the title is going to be. So we can use that information basically to pass in title. And then rather than doing like this hard-coded thing, what we're going to do is we're going to do width minus tw. And there is no such thing as width right now. It's really screen width. And then we're going to divide it by 2. So this is us trying to center basically the text. In this one, we'll do screen height divide by 2. It's going to, actually we're going to do it divide by 3, so it's a little bit up. And then what we'll do is we'll pass the t size, because that is the size of the font. So let's see how this looks when we actually run it. If I could do this, okay, whatever, bin. And now we have like this that's kind of nicely centered, but what we don't have is like an instruction to the user for what they should be doing. So I'm going to change 2 things. The first is I'm going to change this to divide by 4, because I think that'll look a little bit better. And the second thing I'm going to do is I'm going to do const star instructions, and that's going to be equal press space to play. And then what we can do now is we can do the exact same thing as right here, and it'll be const int, and then this will be I size. We'll make it 30 to be slightly smaller. Then we'll do const IW, and this will be measure text, right? And then we can do the instructions. Then we can pass in I size. Now we have that. And now we just need this again. So draw text. We'll pass in instructions. We will do screen width, and then we'll minus IW, divide by 2, because we're still centering. We divided by 4. This time we're going to divide by 2, so it's more towards the center. Divide by 2, right? And then the last thing to do here, pretty simple, is we have our size, and then we have the color, which we'll just keep as white, and then I just need to fix that. And now we have that. So let's actually do this. And now we have press space to play. In terms of the implementation, this is enough, but I think it's a little bit boring. So what I want to add, just for a little bit of flair, if you will, is just make it so that way this goes in and out. And so what we can actually do is we're going to add this variable up here, and we're just going to call it an unsigned int, and we'll call it frame count. And it's going to be equal to 0. At the start, we'll plus plus the frame count of every single iteration before we get into stuff like this. And then I'm going to add one other thing. So this will be basically bool show menu instructions, and this will be true at the start. So now what we're going to do here is on top of this, we're going to have right here, if frame count mod 30 is equal to 0. So every 30 frames, which means every half second, we're going to change whether or not it's showing or not. Show menu instructions is equal to not show menu instructions. And so we're just going to see what this looks like. Maybe it looks terrible and we'll remove it. Maybe it looks good and we'll keep it. So we do that, we do this, and now we can take these and just put them up here, get some reformatting, and let's just see what it looks like. Yeah, that looks pretty good to me. So now we have this kind of like arcadey kind of style thing where we press space to play, and then when we press space or enter, we actually go into it. Actually, now that I think about it, do we actually have that? Yeah, no, we have key space or key enter, so we're good to go. So yeah, now we have this kind of like very basic, just to show it one more time, menu system where like the menu itself is actually something the user can interact with and can see that something's happening. So yeah, that looks good to me. Let's go on to actually implementing Snake now. The next thing we're going to be doing is we're actually going to be implementing the kind of rendering logic. And to do that, we're basically going to have a grid type, right? And there's going to be different types of grids. There's going to be, for example, the empty grid. So we'll name this like grid empty is equal to 0. The other kind of grids we have to worry about is grid food. So this is where in Snake, right, where you collect the food and then you can keep going. But there are other kinds of grid types that we're going to be actually implementing. Specifically, we're going to have grid north, grid east, grid never eat soggy, and then waffles is the last one. And basically what we're going to do, instead of like the standard approach, which is a linked list, what we're going to, for Snake, is instead we're actually going to represent the whole direction of the snake and its size through these 4 tile types inside of our grid. So the next thing I want to do is actually decide how big our grid is going to be. And I'm going to say for us, it is going to be const, and it's a square, by the way, so we just need basically a size. We'll make it int just because we're going to be dealing with checking bounds, so just negatives are going to be annoying. So we'll just do int to make our lives just a tad bit easier. And we're going to make this basically the dimensions dimension for this, and we'll start with like a 10 by 10 board. We can come back to it later if we don't like it. And then what we're going to do is we're going to have our grid type, and we're going to have our grid, and we'll just have dimension, dimension, and then we're just going to zero it out for all of them. And I think this is going to actually give us an error. Let's actually see the exact error, so life is a little bit easier. But no, it's just, this is totally fine. Yeah, I'm okay with a variable length array for this kind of thing. So we're basically just creating a two-dimensional array. If we want it to be a little bit more clever, if you will, we could do it like this, dim times dim, right? And then we could always just make this define dim 10, and then we can get rid of this, right? And then I kind of want to make this like a little bit bigger, so we'll make it like D, and then we can just handle that. Oops, D, right? And then we get that, and we zero it out. But just for now, just to keep life a little bit easier, we're going to do two-dimensional array. We'll zero it out so it's empty. And then what I also want to do, because right now we're not going to actually be implementing like movement or anything related to the snake. We're just going to be using this grid basically to handle the rendering, basically. So the other thing, just before I forget, snake size is equal to 1. But we're not actually going to be doing anything else. So we have our grid right there. And now what I actually want to do is I want to say grid 1, 1. This is going to be, actually make it like 1, 6, let's just say, is going to be equal to grid north, right? Just for simplicity. And then we'll say like grid 6, 1. Really doesn't matter what these are, is going to be grid food. Where is it? There it is. All right, so we're just going to use that as our testing, and basically when we're rendering, we should see these different values. So let's go all the way down here, and let's actually get to rendering. So we're going to get rid of this for right now. And now we actually have to figure out how we're going to be rendering this grid right here. And so the first thing to realize is that it's going to be basically constant. So what we can do is we can say, based on this, there's const int, and it's going to be basically like grid D is going to equal to screen width divide by D. And we have like a guarantee right now that since these two are the same, this will be the same. So we don't have to make like an X and a Y. We can just use 1. If we wanted to be a little bit more flexible in our code, let's say, we could totally add, like make this like a vector 2 and then have X and Y. But because we know what we're implementing, we can be a little bit lazier, and that's okay. So let's go down, and we're going to be using this to actually implement stuff. So we're going to start by basically saying that in our, let's actually run this real quick so I can kind of show you with my mouse. In our play area, we don't actually want to take up the whole space of like rendering because it'll look a little bit gross. Really, we want to take up like a subspace of here. So maybe like we'll leave 10% on both sides. So the way we can actually do that is we first go up here, right? Because in all reality, we have like our actual width. So const int play D is going to be equal to screen width times 0.8f. And then we can cast it to an int after the fact. And then this, instead of being screen width, right, we're going to use play D. So this is basically the total width, and then we also are going to basically have our const int start D, start X. We'll just start D actually for simplicity. And then we're going to just take this again, right? But instead of being at 0.8, we're going to be 0.1. And we're doing that because even though we're ignoring like this and this, we're starting, which is 20% total, we're starting over here, and we're going to end up over here, which will be at 90% of the screen width and 90% of the screen height. So hopefully that makes sense. And if it doesn't, maybe it'll make a little bit more sense once we're actually here. So what we need to do, right, is int y is equal to 0, and then we have y less than d. sorry, plus plus y, and then we can do for int x is equal to 0, x less than d, plus plus x, right? And now we can actually start to figure out where we're going to be rendering on the screen. So the first one we can figure out is where we're rendering in our y. So constant y sub r, let's just say. And then maybe we actually make this, for convenience, we'll make this like y sub i's and x sub i's. So it's kind of like maybe a little bit more clear that we're dealing with indexes here. I guess that doesn't want to work for me right now. That's okay then. And so our render is basically going to be the play d plus y times, and then what did I name it? I think I named it grid d, yeah. Y sub I. And I'm going to put these like this, like this. So now we have like where we're rendering. And now we can actually figure out this too based on this, but instead of y, we're going to make it x. And now we basically have where we're going to be rendering, but now we need to actually figure out what we're going to be rendering. So what we'll do is we'll call a switch, and then what we'll take in is our grid, and we'll put in y first, then y sub I, sorry, then x sub I, because that's our index. Now we have different grid types, right? And basically what we need to handle is what happens. So I'm going to put default and empty next to each other, because if it's empty, we're not going to do anything. And now what we need to do is handle these ones right here. So if it's north, east, south, or west, our behavior is going to be actually exactly the same. What we want to do is we want to draw a rectangle, and I just want to, where is it? Horizontal. I don't want that, just draw a rectangle. Maybe let me go to actually the cheat sheet real quick. Rectangle or Raylib cheat sheet, right? And then I'm pretty sure there's just a draw rectangle where you actually just get to do, because this is what I want right here. Yeah. So we can just call draw rectangle, and then we need our positions. So we have our x sub r, our y sub r, and then we need to handle our width. So this is going to be d, and it's not actually going to be d, it's going to be this right here, grid d. Grid d, and we're going to do -1 for both because we don't want to like overwrite the next part. And then for the snake, we'll make it so it is a red snake, let's say. And that looks okay to me in theory. We'll see if it actually works when we get there. And then for this one right here, we'll make it so it is a green snake. And let's double check here. So we get our x, we get our y, sorry, play d plus yi times grid d. And yeah, I think that looks right. Let's see what actually happens though. And then I think the problem is going to be, we have our play d, but I have this start d. This is the problem. It was too far out. This should be start d, start d. And we may not even use the other one, but yeah. So now we're actually rendering properly, which is always nice to see. If we really want to be like super careful, just to make sure everything is behaving how we want, we can, and we'll just make this like a blue just for now, right? See, make it, build it. And when we run, you can see everything is blue except for the ones that we set. And we could even like use this behavior, right, to basically change it. So like the outline was this, and I actually kind of like that. So maybe we'll actually keep this blue. I think down the line we'll create like a custom color. But for like our initial just testing, this is actually pretty convenient to see. So we're going to keep this like this. We have snake. We can always add a title up top here if we want, or like a score, for example, to measure how long the snake is. But for now, I think this is a really good starting point. So let's go into the next part of implementing snake. So now we're going to be implementing movement, and I actually already did it, but the recording got messed up. So I'm just going to give you a quick little highlight of what happened. which is basically we created this structure with a point which has x and y, and we used integers just for convenience because we're going to be doing some bounds checking in a little bit, specifically because of this function right here, where basically we take in a point and a grid type, and we have some guarantees that basically we're not going to be dealing with grid empty or grid food, but if we do, we just assert false and break. But otherwise, we're over in this territory where basically, if we're going to the north, just for example, Raylib is going to have this as 0, 0, so the top left is like the origin, and then over here is going to be screen width and screen height, so in our case 800, 800. And so in our case, basically, if we're going to the north, that means we're going up. If we're going east, that means we're going to the right, and then the rest is pretty self-explanatory. But this is a little function, and that handles that. What I also added was this right here. So we have our snake head and our snake tail. And then I have our snake direction. So that is the direction we're currently moving in. And then I removed the code that was here, which was something along the lines of like 6, 1 is equal to grid east, for example, or west, I guess I typed. And then I think I had like 1, 6 for food. But I got rid of that, and I just initialized it to 0, and now I have these snake head, snake tail. And then if we go down to here, this is some code that I added where basically before we were just changing the scene, and now we actually do some initialization. So the first thing we do is we reset our frame count to 1, and we're specifically interested in that because down below over here, you can see we're going to be using the frame count again. And we just don't want like the first frame to be something that has movement for the player. But anyways, so we have our snake head and our snake for x and y, and we initialize it to d divided by 2. So really this is just 5 and 5, but if we decide to increase d, then it could become larger or smaller, whatever. And then once we've initialized this, we set the snake tail equal to this. And I actually just found a little mistake because we have our snake size. This should be initialized to 1. Because it's going to be size 1 at the start. But with that, basically we have our snake head, we set our snake tail equal to that, and then we initialize the direction to always being going up or north. And then what we do after that is we update this right here. So in the grid, we set the x and y position to be equal to the direction. And basically the reason why we're doing this whole thing is because we're going to be using the directions in the grid basically to direct where the snake is going. Specifically, it's going to be relevant when we get to the tail movement code. But so we just update this. We set something to be food. We'll actually update this later on to be a little bit more intelligent in terms of how we find empty spots. And then, yeah, we reset. So that takes us to the movement code, where basically all this code right here is the exact same kind of structure, where we check for the different key presses, so W and up for when we want to go up. And then this code right here, right, where we check for the direction, is basically to handle this kind of situation, where basically imagine we have a snake that is going downwards, like so. So this is the head and we're pointing down. There are cases where if, for example, I pressed up or W in this case right here, where the snake head would then basically become like this, and then there'd be a collision with the self. And for some implementations, that's what they want. For my implementation, I just don't like this behavior, to be totally frank. So what we do is we make it so if you're facing down and you just move down, the only things you can do is this or this, or this, but you can't go back up. So that is just one, and then these ones are the exact same, but now we're handling when we're going to the right, when we're going down, and when we're going to the west. And now this is where actually the code gets kind of interesting. So I'm going to comment this part out real quick. And basically what we're doing here is we say snake head of y and x, so where our current thing is, we set it to the direction that was set here. Oh yeah, and sorry. What this is frame count mod 30 is equal to 0, is basically saying every half second, because we're going at 60 frames per second, when this is 0, so every half second, we're going to update the snake's position. So what we do now is we set the current position the snake is at to the direction that it is going to move into. Because that's really important, because we're going to use that basically to update the snake as it's moving along. But then what we do is we use that function point plus direction to get the new snakehead position. And we could also pass this as a reference, and then this would be a little bit cleaner maybe, but that is okay. And then we do snakehead.y, and then snakehead.x for the new position. And all we're doing is we're just setting it to the current direction. But we expect this to change, and that's okay, but we need something to render. So when we just use this code, and I'll make it like so, and then in a second, it will work. And then we can do bins project, and we press space. So now you can see basically we're not actually clearing anything right now. And we're also not actually hindering collisions with the self at all, but basically right now we just have a way to paint into our grid, which is obviously not what we want. What we want is for basically this over here to be running. And so what this is doing is it's using the tail position. So it stores the temporary direction. Then what it does is it sets the tail to empty, because basically the tail is always going to be replaced with an empty cell. And then what we do is snake tail, we plus that direction of where we were. So that's why I'm basically saying we're leaving breadcrumbs over here for the tail. So when we actually run this now, and we press space, now you can see we get this behavior that you would expect with a snake, where like if it's only size 1, right, it's going to just keep going. And then when we actually start increasing the size and handling collisions, then we'll be able to do more. But right now we're not handling this. And so actually we get this kind of like funny behavior where I guess it's going to wrap around. But when we go this way, and then eventually once we do this, we get a bug because we're now going out of bounds. Now that we actually have movement, what we need to actually handle are some basics like collisions and making sure that basically if we collect food, we're actually going to see that reflected. So I'm going to start in this section by just covering how we handle food. So I'm going to go to this right here, and we're going to have our grid, right? And it's actually going to be based off of this direction where snakehead goes to. So before we set the new direction, we need to see if there's anything else there. Snakehead.x, right? And now we need to handle this grid empty. And so if it's the empty condition, right, there's nothing to do here. We just keep going. And I'm also going to handle this with the default condition and just say if anything's there, we don't actually care. Let's just move forward. So that is that. In these cases, though, ran into snake. And in this case, we need to do a to-do handle player lost. But for now, all we are actually going to do is we're going to say, what did I name it? Current scene is equal to scene menu. So the player lost. Good enough. Now, our other case is actually when we run into food. So what I'm going to have here is basically plus plus snake size, and then I'm going to have food collision is equal to false, and then I'm going to have food collision is equal to true. And actually, I'm actually going to disagree with myself. I'm going to disagree with myself. We're actually going to update it like this. So if we didn't do this, if it's empty, we're going to put this right here. Going to do this. This goes up here. Do the formatting, do that. And then that looks good to me, right? And in this case, right, we're actually just going to leave this. And I think this is actually just going to work. And we can test it really quick. So let's take a look. And we can see if I'm actually, there was an unused variable. Actually, no, that looks fine. Okay, let's take a look. So I'm going to collect this food. And now you can see it's actually just working like what we thought it would. So let me run through this code just so this makes sense. So basically, When we run into food, we're not going to empty the tail like we do when we run into an empty grid location. So basically that implicitly makes it so that way there's one more thing to handle. And this is now able to correctly follow that trail of breadcrumbs basically that we've been leaving. So actually before I stop, I want to increase this, by the way, just a little bit to like R7, 8, and let me do it for like this, and then let me make this like 5, whatever. And then I'll order it just because I have to. I don't have to, but I feel like I have to, let's say. And then I'm currently not using the, okay, so this is looking good. We're at 3. Let's make it a little bit bigger. Now we're at 4, 5. And now you can see everything's working. And now I'm going to collide with myself, and you can see we already have a lose condition. Now it doesn't look very good, right? Because we just go straight back to the menu scene. And that's something we can actually look into fixing down the line. But for right now, we're actually kind of good to go. So the next thing to do, since I'm kind of on a roll, I think we're going to do the next one, which is basically how do we handle the case where this is now out of bounds? And that is actually very easy. So if we wanted to be kind of like very efficient about it, right? We could actually do some bounds checking before up here. We like this would actually go down there and then we could actually update, but I want to just kind of do it this way instead, where if snakehead.x is less than 0 or snakehead.x is greater than or equal to d, then we're out of bounds in the x direction, right? Or snakehead.y is less than 0 or snakehead.y is greater than, and then this would be greater than or equal to d, right? Then we're basically out of bounds, and we could say something along the lines of scene or current scene, sorry, is equal to scene menu. Else, then we actually can continue with this stuff. So now we have to take this and put this in here. And so now that's actually handled. So let's do a quick little run and see what it happens. So I'm going to go up and see if we get right back to our menu scene, which we do. And you can see we also have an error with how we're resetting, which is kind of fun. So we'll fix that in just a second. And now we'll go down, collect these as we're going, just because. And now you can see we have some bugs. So let's fix those bugs, and then we'll come back to it. So we're in here. Basically what we need to do is we need to update all of this. Y is equal to 0, and then I actually need to use size t. Nope, that is not the fix I wanted. I wanted to do this. Y is less than d plus y, and then we can do this. Size t x is equal to 0, x less than d plus x. And now what we can do is this, fix that, and then we can just do grid empty. Okay, so now if we run this, and that should fix that bug. So let's go all the way up. We reset, and that did not fix it. So in scene menu, we set it to grid empty. Oh, it's because I'm using this. There we go. Whoops. So let's rebuild, rerun. Let's go up, and let's see what happens. And we're good. I'll do this one other check, which is kind of like, we collected a lot. Do we properly reset? And we do. So that is actually all we need to handle collisions and to handle the other case of where we kind of go out of bounds. All right, so next up, we're actually going to deal with food placement. So I'm going to be using some randomness. Let's do like time, and then we can do null and see if this works. And that seems to work, and that's fine by me. And so the next thing to do is actually update how this is handling. So we're going to be using a function for this, actually. Place food, and then we're going to pass in the grid, and we're also going to pass in the snake size. And now we actually need to handle this, and we're calling a function here because we're also going to do this right here, where if we collect food, we need to actually use this function. So let's actually define the function now. So void this, and then we're going to pass in terrain. What did I call it? Was it grid type? Grid type, grid, and then it's going to be like star star, because that, and then we'll have an int. We can make it const int snake size. All right, cool. So let's make sure that this is working in terms of this, and it's saying no. So I think we can just do terrain. Well, we can actually just set this because we actually know exactly what it is. Even though I don't love it in theory, I don't mind it. Now we get this thing. Yeah, this is probably right anyways. Okay, so let's do this, and then we'll make it static inline because why not? And now we can actually start programming. So there's basically going to be two cases that I think are worth considering, which is if we can imagine like a big grid, right? So let's just say like this is our grid, and I'm just going to do one more line and say like this is the area that the player is playing in, right? If we're relatively, like if all these X's, for example, are going to be where the snake is not, but if I do this and do this, right, and all these S's all of a sudden are where the player actually is, like the difference I think is actually kind of massive in terms of how we want to go about finding a place where we can put these, basically where we can place food. So the way I'm going to go about it is I'm going to have two cases where the first case, if snake size d times d, and then this is the total size, and I'm going to do the, well actually I don't need to do parentheses there, that's a bit overkill. Divide by 2 is greater than, is actually less than snake size. We're going to do some work. But if this is not the case, so basically the snake size is less than this, so at least under half is going to be less, what we're actually going to do is we're just going to do like a generate and test approach. So what that means is we'll do like a do while for this, and then let me do this, and then I accidentally did, there we go. Okay, so basically what this is going to say is we're going to have this little point here, and we'll have point P, and then we'll say P is equal to, and then let me actually check Raylib's documentation, which is get random value. P.x is equal to get random value, and it's going to be between 0 and d minus 1, and then we can do this twice for y. And then what we set it to is while grid p.x, p.y, sorry, p.x does not equal grid empty. And when we actually find something where it is grid empty, right, then what we can do, actually, we should actually be a little bit more intelligent about this, point P, and then we can do this over here where grid p.y, p.x is equal to grid food. So this is our first case, and we don't actually have to worry about this right now. So let's actually see if the logic is right and it kind of works. Bin project. So we press space and we'll collect some food. And now you can see we're kind of off to the races in terms of actually playing the game of Snake, which is kind of cool. Now I'm going to let this run for one more second, and then we'll just kind of stop. So the other thing to figure out is this one right here. So if we run into this case, then we actually have to do some work, because all of a sudden it's going to become less and less efficient to just continually guess and check. So instead what we're going to do is we're going to create a set of points, and it's going to be based on d times d. All right, and then we'll also have a size t. Let me actually put this like this. Size t len is equal to 0, right? And so then what we have to do is size ty is equal to 0, y less than d plus plus y, because we're going to be looping through this entire array now, plus plus x. And then we have to figure out is if this is basically if grid yx is equal to grid empty, then this is a place where we can place food, right? So what we'll do is we'll say p dot p len, and then yeah, just len, and that is equal to dot y is equal to y, and then this will be x, and then because we're using size t, we'll use integers because the points are using integers, not size t. But now we do this, and then the last thing to do is plus plus len. I'm sure some people would, yeah, I don't like when like you do like this, for example. I think that's just hard to read. But basically we increase the length, and now we basically have an array of the number of points that we can select from. And so then what we can do is we can say p is equal to, and this is wrong, right? It's not p because that's up there, so we need to update this. Points, and then we can do this is equal to points, and then we can do get random value, and I want to check get random values documentation real quick. Where int max both included, yeah, both included, so that basically we want to do d minus 1 there, and then we want to do len minus 1. And so we can do this, and then basically it's saying that it wants this as an int anyways, so we'll just make it an int because I don't really particularly mind. So now we're setting this, and now we're doing that. So what I'm going to do, just briefly, is I'm going to go if true. So this is always going to value to true. And then we can run it. We can do this. Compress space. We can do this. And now you can see we're also getting random values. Looks good to me. So yeah, this is kind of the basics of Snake, actually. We have food placement now. If I run to the edge, you'll see we're about to lose. 3, 2, 1. We can go again. And now we have like stuff generating. And I just ran into myself there, which is why I died. And yeah, so that all looks good to me. Is there anything else? This is code will never be executed. That's absolutely true. So let's fix this, do this, and now we have food placement working. Now there's still stuff to do. For example, like we don't actually have a win condition yet, which we can actually just do in just a second. But we also don't have like any like win-loss screen, which I think we're gonna do. So I think the last thing to actually do in terms of the implementation is add a win-loss screen and then actually handle the win condition. So yeah, let's get on to the next part. All right, so now let's actually handle the case where the players won and the players lost. So I'm gonna make 2 new scenes, scene win, scene loss. Pretty simple. And then all we need to do now is we need to handle this kind of behavior. So in the first case, there's the scene game, and we just need to handle where the player lost. So instead of this, we're gonna do scene lost. And then the other case is up here, scene lost. And now that's all we need for that, but we need to handle the win condition too. So basically in this one, if basically snake size is equal to, we'll make it, yeah, just equal to d times d. Then we have the win condition, else, that's rough typing. For me, we can do this. I feel like Clang isn't actually formatting right now, which is okay, but whatever. And so once we're placing food, either we're going to place food once we've gathered food, or we've now collected it, so our snake size has reached the size of the total grid. And if that's the case, what we want to do is current scene is equal to scene win. And so now there are two more things to do, right? We have this behavior right here, but we're not handling the case of scene win and scene lost. So we have to do that now. Case scene win. And then we'll do some stuff to make this work. And then we need case scene lost. And then again, we'll do some stuff to make this work. Specifically, all we're going to do is basically say, how are we going to handle this? We could, for example, reset the frame count, but I think a better way to do this would be basically we're going to say if key press is key pressed, and we'll have key space, or is key pressed key, and it'll be like enter, right? And then we'll go current scene. Well, I don't. All right, I'm changed my mind. I don't love this whole key press thing. I'm just gonna say if frame count mod 30 equals, we'll make it, yeah, mod 30 equals 0. We'll do this, and then we'll do scene is equal to scene menu or game. Sorry, there we go. And we'll have this, and then actually this behavior is going to be the exact same. So we don't actually care about that in terms of like, there's no reason to double type it. Where if it's lost or win, we're just going to wait till we get to frame mod 30, and then we'll do that. And just to make this a little bit longer, because I feel like, yeah, we'll do it like 60. And then what we'll do is we'll do scene win, right? Frame count equals 1. We'll copy that. And then there's one other loss condition, which is down here. And I believe that's it. So we can do this. And that looks good to me. I'm going to add this now, just because that got a little long. Boom, looks good to me. And then that looks fine to me. Let's actually do that as well. And that looks good to me. And now we have that, but what we don't have is rendering. So let's get to rendering. So we're gonna have case scene lost. Scene lost is fine too, I guess. Break, and then we have case scene win. And then we'll do this. Let's make sure we're compiling still correctly. And things look not okay. So what is wrong with this? So this should be current scene, and then this is supposed to be scene lost, and then what is, yeah, so scene lost. Let's see where I made that mistake. Lost. Okay, so I think that's all good now. And now if I just do a scene make build dot, we can fix that. Lost. Any other cases? I think everything else should be good. And yeah, so we're all good. Okay, so now we can go back into rendering, and now we basically just need to handle like basically this right here. So I'm actually just going to take this whole thing, and I'm just going to copy and paste it because I can. So the title is going to be "You Won," right? And then we'll make it, that seems fine to me. Otherwise, we're going to do this. You lost, right? And we'll do a sad face because we're sad, and we'll make it red because it's a loss. So that's that, and it's ready to go. What else? We have that. That looks good to me. So let's actually see what happens when we run it in project. And I'm just going to lose real quick. You won. Doesn't look right. Oh, so it's reversed. So let's fix that. All right, let's fix the formatting now. CMake it, run it. Now we test. Losing again. Looks good. That unhappy face is actually pretty terrible looking. So let's try, instead of that, let's try like a parenthesis for a more classic look. And now we'll run into the wall again. You lost, that looks great. And now we can handle the other case of, first of all, I want this to last a little bit longer. So I'm gonna go like 90. So this is 1.5 seconds. And then if you won, basically what we need to do is actually test it to make sure the logic is working. All right, so there's a playthrough of winning working correctly, but I did notice something a little annoying, and you notice that I changed D equal to 4 just so we could see winning working. And let me actually make it a little bit bigger now. Basically what I was noticing was some annoying behavior when I was testing, where basically if I get it to size 3, I should be able to show it. Where basically I can lose if I'm like very fast. And I'm pretty sure this is because I have my movement logic a little bit off. Where snake direction can be updated, but it's not actually snake direction that we care about. It's actually head.y, snake head.x. That is what we actually care about. So that is a little bug fix, because really we care about not about what our temp next direction is, it's what our direction was. Okay, so if I do it like that, now I think, let me go collect 3 real quick. So yeah, so now that actually doesn't work, which is perfect. Yeah, okay, so that is a full game of Snake actually working. We have a win-loss screen, we have a win condition, where we're basing it off of actually, like, if you have completely filled it in. We have actually what I think is reasonably intelligent, like a reasonably intelligent way to place food. And yeah, let's see how many lines it took. It took a total of 353 lines. So yeah, that's Snake. It's not necessarily the most beautiful Snake you've ever seen, that's for sure, but it is a full implementation of Snake in C with Raylib. So yeah, thank you so much for watching, and yeah, everything's going to be linked in GitHub in the description down below, and thank you for your time. Bye, everybody.